Finding the right tool for the job shouldn't require digging through every option in your MCP server. We'll filter tools by their FastMCP metadata tags to instantly locate exactly what we need, like isolating all analysis tools with a single list comprehension. You'll see how the FastMCP namespace organizes custom tags and why this pattern beats manual inspection for large toolsets.
Async with client. Tools equals await client list tools. Hash filter tools by tag. Analysis tools equals. Tool for tool in tools. If hassetter, tool, meta and tool meta end. Tool meta get FastMCP end. Analysis in tool meta get FastMCP. Get tags. Print f found len analysis tools. Analysis tools.
This demonstrates metadata-driven tool discovery, a pattern where executable functions are dynamically filtered and selected based on declarative tags rather than hard-coded references. The approach treats tools as first-class entities with rich descriptors, enabling runtime discovery and categorization without modifying the underlying implementations. What makes this distinctive is the separation between tool capabilities, what they do, and tool classification, how they're organized, managed entirely through metadata. The pattern works by embedding classification data within a standardized metadata namespace, creating a consistent discovery interface while avoiding collisions with application-specific metadata. Tools expose their capabilities through a structured metadata field, and clients filter these tools using declarative queries against tags or other attributes. This creates a loosely coupled system where new tool categories can emerge without changing the discovery protocol or requiring client updates. This approach solves the problem of tool proliferation in complex systems, where manually tracking and referencing hundreds of tools becomes impractical. It enables dynamic toolchains where components can be discovered and composed at runtime based on their declared capabilities. The trade-off is slightly increased initial setup for metadata, but the payoff comes in maintainability. Adding new tools or categories requires no changes to existing discovery code, only metadata updates. Let's break it down line by line.
Async with client.
This establishes an Async context manager for the FastMCP client connection. It guarantees proper resource cleanup when the block exits, preventing connection leaks. The pattern is essential for Async operations where manual cleanup would be error-prone.
Tools equals await client list tools.
This fetches the complete list of available tools from the FastMCP server. The await is required because list tools is an Async operation, and we need the result before filtering for analysis tools.
Hash filter tools by tag. Analysis tools equals.
This begins list comprehension filtering to isolate analysis-specific tools from the full toolset. We're transforming the raw tools list into a targeted subset, which eliminates irrelevant tools before further processing.
Tool for tool in tools.
This is a list comprehension generator expression. It iterates through each tool in the tools collection, enabling the subsequent filtering logic to process them one by one. The pattern efficiently handles iteration without creating intermediate data structures.
If hassetter, tool, meta and tool meta end.
This performs defensive attribute checking before accessing nested properties. It first verifies the tool has a meta attribute and that it's non-none, preventing attribute error or key error when traversing the metadata structure. This is the standard pattern for safely accessing potentially missing nested data in Python.
Tool meta get FastMCP end.
This is defensive dictionary access. It safely checks for the FastMCP key, returning an empty dict if missing, preventing key error exceptions. The pattern handles missing metadata gracefully while maintaining the chain of dictionary lookups.
Analysis in tool meta get faster. Get tags.
This checks if the tool has the analysis tag in its FastMCP metadata. The nested get calls safely handle missing keys by returning empty dictionaries or lists, preventing key error exceptions. This pattern ensures we only select tools explicitly marked for analysis tasks. This closes the list comprehension, finalizing the filtered list of analysis tools. The square bracket terminates the expression, ensuring Python evaluates the entire comprehension and assigns the result to analysis tools.
Print ffound len analysis tools. Analysis tools.
This outputs the count of filtered analysis tools, providing immediate feedback on the filtering operation. It verifies the list comprehension successfully isolated tools with the analysis tag, confirming the filtering logic works as expected. FastMCP metadata filtering. The tag-based filtering pattern lets you dynamically expose or hide tools by inspecting the fast metadata namespace, creating flexible server configurations without modifying component definitions. The meta field exists on all MCP resources, but FastMCP's fast subnamespace is optional and controlled by server settings. Always verify metadata presence with hasadder and defensive chaining before accessing nested keys.
The tool that hides behind a tag becomes the only tool visible.